I think I'm live. Good evening, everyone. Good evening, good evening, good evening. How are you? कैसे हैं आप सब? A very good evening, guys. So, for those who don't know me, my name is Manish Mishra. I secured an All India rank of 568 in GATE 2015, and since then I have been teaching primarily for GATE and ESE. I have a cumulative experience of 5 years in teaching, and the subjects that I primarily take are manufacturing science, industrial engineering, operations research, and material science. So, guys, this was a brief introduction about me. Good evening, Ashwin. Today you are the first in the class. Ashwin, the future scientist. Oh my god. Very nice, very nice. Good evening, Arunopal. Come on, guys, hurry up. Where is everyone? Come on, come on, come on, come on, come on. So, guys, in the last class, we were discussing about queuing models or queuing theory. And in this segment, we have reached up to the point. Let me just take you guys there. Let me just take you guys there. Okay, 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 okay. So this was it, the classification of queuing models. This is where we were in the last class. I think we should have a quick revision. Okay, so let me just give a quick revision to all of you. Let me just give a quick revision to all of you. So guys, up until the last class, we have discussed that as a customer, the length of queue, the length of system, the waiting time in the queue, and the waiting time in the system, these four are of major concern. If I am a customer and I will have to join a queue, then these four things will be of prime concern to me. And if these four things are of prime concern to me, then it becomes more important, or it becomes a greater concern for the individual or for the machine or for whomsoever I am talking about, who is running the system, who is in charge of the system. Okay, so let me just give a quick revision. So because these four things are important for the customer, it becomes of higher importance to the system owner, whomsoever is in charge of the system. So what we have learned up until now, that what queuing theory does, it demands certain data points, and using the concept of probability distribution and the six data, it just simply provides us these four values. Okay, so up until now we have studied about the characteristics of queuing model. We have studied about the characteristics of queuing model, where we have learned what is calling population, what is customer, what are arrivals, what is average arrival, what is average service, what is queue, what is system, okay, what is a service station. These all things we have already covered. We have covered each and everything in detail and with definition. Okay, guys. So now let me just move on. So now the next thing that we should be doing, is Kendall's notation. Okay, Kendall's notation for representing queuing models. This is very, very important. Very, very important as far as the numericals are concerned. This is very, very important. If you guys have checked the GATE syllabus, the syllabus of GATE of Industrial Engineering and Operations Research, then there you must have seen under the Kendall's notation, it has not in Kendall's notation, it has been specifically mentioned under the queuing model that we only have to study the MM1 FCFS infinite queuing model. This is the only queuing model that we have to study. Guys, I don't know what happened, but students have not yet joined the class today. I don't know what is going on, but yes, students are not in the class today. I think I should continue. Let them join on their own sweet time. So, so now classification of queuing models. Okay, I will go back to the Kendall's notation. Don't worry, guys. I will go back to the Kendall's notation. Let's just look at the classification of queuing models. What is this? Guys, I specifically told you that queuing theory will ask you about 6 data points. What were those 6 data points? What were those 6 data points about queuing theory? Okay, so it was lambda, that is the average arrival, mu, then type of service, that whether it is first come first serve, sorry, lambda, mu, then number of server, that how many people are there, how many points are there where you can opt for the service, like whether it is a first come first serve, whether it is a single server system, a two server system, 3 4 whatsoever. Okay, so lambda is the average arrival rate, mu is the average service rate, and number of server simply represents how many people or how many points are there where the customers can seek service, whether it is a single server system, only one barber is cutting the hair, two server system, two barbers are there cutting the hair, and etc. So lambda, mu, number of server, that sums up for the 3. The rest of the 3 are type of service, that whether it is a first come first serve type system, that whether it is a first come first serve type system or a last come first serve, so that is type of service. Then we have number of people in the system, number of people in the system, and last we had the calling population. So these were the 6 datas that the queuing theory requires, so that it can process this data with the help of the concept of probability distribution and provide us with the required information. So guys, lambda and mu I have already told you in the last class, these are the average arrival rate, the rate with which customers are arriving. When I say that the value of lambda is 5 per hour, it means on an average, every 5 customers arrive in a span of 1 hour. On an average, mark my word, these are very important, on an average. Okay, because if somebody will ask me that lambda is 5 per hour, then how many people will come in the next 2 hours? So the answer will not be 10, guys. Answer will not be 10. The answer will be such like this, that on an average in the next 2 hours, 10 people may come. Okay, there is always a possibility, always a probability. Therefore, remember lambda and mu, they always follow certain probability distribution. It will be given for the value of lambda and mu, that which concept of probability distribution they are related to, whether it is normal distribution, Poisson distribution, gamma distribution, whatever may be the distribution, or whether lambda and mu are deterministic. In some cases it can be like this also, like if I will say that lambda is 5 per hour without any distribution, it is exact deterministic. On an average every 5 hour, sorry, not on an average, in an hour 5 customers will come. If lambda is deterministic, they have said it clearly that lambda is deterministic, then in that case, my friends, in the next 2 hours 10 customers will come. Okay, then number of servers, 1 2 3 4, whatever may be the value. So remember, I have told you guys in the last class that the number of servers is from 1 to n. Then type of service, there are 4 types of service: FCFS, LCFS, etc., etc. Number of people in the system, remember I specifically told you there are 2 types of system in which there is a possibility when we restrict the number of people in the system. So that system we called as a finite system, where we keep a restriction that only 10 people, 15, 20, 15,000, whatever may be. But if I will keep a restriction on the number of people in the system, that system will be called as a finite system. Okay. And if there is no restriction, then infinite system is what we consider. Infinite system is what we consider, which basically means that theoretically there is a possibility that infinite people can join the system. Infinite people can come in the system. There is a theoretical possibility, and we will have to consider that while calculating the values. Okay. The last is calling population. Again, for calling population, remember we have two kinds of criteria, finite and infinite. As we discussed in the last class, for Unacademy, the calling population is finite. They can only market to those customers, those who are preparing for GATE and ESE examination. For finite in calling population model, this simply means that there is no restriction to the number of people who can join the system. No restriction whatsoever. If I am talking about a barber shop, a saloon, then there is no limit to the number of customers. The calling population is infinite because people will require a haircut in every 15 days. And whomsoever, whether you are a man or a woman, an old man, an old woman, a child, you require haircut. Okay, so saloon, they have no limitations to the number of customers. So that is an infinite model system. So guys, that's it. I have revised each and everything for you. So guys, basically what is Kendall's notation is, because there are so many variations to these 6 points. So many variations. I mean, there could be a situation when lambda can be probabilistic or it can be deterministic. When mu can be probabilistic or it can be deterministic. When number of server can be 1, 2, 3. That means it can be a single server system or a multiple server system. When I say a single server, it means only one person is going to provide you the service. When I say multiple server system, that simply means there are more than one servers. Okay. So based on these 6 data points, and because these 6 data points have various possibilities, either a finite model, infinite model, single server, multiple server, lambda, mu, probabilistic, deterministic. So there will be a lot of permutation and combinations. And guys, what Kendall notation basically does, it is a way to represent all these 6 data points into single letters or single alphabets. So basically, whatever the queuing model you go for, whatever are the parameters of those 6 data points, this single nomenclature works everywhere. Kendall's notation is basically a nomenclature for queuing models. Okay, it is a way to represent the queuing model, so that by just looking at that name, that MM1, FCFS, infinite, I will get an idea about all the 6 parameters that we are interested in. This nomenclature, just by looking at this nomenclature, if you go through with Kendall's notation, you will get this, that if you just give a look at this name, you can able to understand that what this means and what are the 6 data points, what are those 6 parameters that we are going to rely on in order to forecast or find our values. Okay, so guys, now let's see Kendall's notation, it is like this: A, B, C, D, E, F. Okay, A slash B slash C, ratio D slash E slash F. Now what is A? A represents arrival rate distribution. Okay, whatever the value of lambda, whatever may be the value of lambda, remember, if lambda is an average arrival rate, then lambda can be probabilistic or be deterministic. And if lambda is probabilistic, it is bound to follow certain probability distribution. So this first letter A, first alphabet A, is all about the arrival rate distribution. What is the distribution? What is the probability distribution that the average arrival rate will follow? Okay, remember this. Then I will come to B. B represents the departure rate distribution or the service rate distribution. Whatever be the probability distribution that mu will be relating to, B will represent that. Okay. Then come to C. C will simply tell you the number of parallel servers in the channels or in the system. If it is a single server system, the value of C will be 1. If it is a multiple server system, like say 2, 3, 4, 5, so that way from 1 to n, the value of C will vary from 1 to n. D simply means service discipline, whether it is first come first serve, last come first serve, or whatever may be the situation. E represents the maximum number of customers allowed in the system. Guys, all the 6 points, all the 6 data that I have discussed, A, B, C, D, E, F, basically represents only that. F represents the calling population. But remember, the only thing that you have to understand here, that A and B do not tells you the value of lambda and mu. It simply tells you the probability distribution on which A and B, lambda and mu are based on. Okay, so guys, let me just go on with this. Let me just move ahead with this. So now symbols for A and B. We have now understood what A, B, C, D, E, F means. Now, what we will be writing in place of A and B. So that is the meaning of symbol for A and B. Okay, so if the symbol for A and B is capital M, if instead of A and B we are writing capital M, okay, what does this mean? It means that the arrival rate or the service, it follows Poisson distribution. Okay, when I write capital M in place of A and B, it simply means that it is Poisson distribution for arrival and exponential distribution for service rate. That is the simple meaning of that. If you can see simply M here, remember A and B, that is average arrival and the average service, they follow Poisson distribution. If instead of A and B I write EK, then it means it is Erlangian or gamma distribution for arrival and for service. तो EK simply represents gamma या फिर Erlangian distribution. GI represents general independent distribution. General independent distribution means it is a completely new concept of probability distribution. Never ever anybody has ever heard about this. It has its own function, own graph. Everything will be unique, but it will be a general distribution and data will be provided for that. Okay, and remember, if it is D, then it is deterministic. If it is D, if A and B, instead of A and B it is written as capital D, then remember lambda is 5 simply means that 5 per hour. Lambda simply means that in the next 2 hours 10 will come, in the next 3 hours 15 customers will come. So guys, I hope now you are able to understand what are the symbols for A and B and what are their meaning. Let me proceed. Now let us discuss the symbol for C. So A and B we have already done, and remember C is number of parallel servers, so I have already written 1 to n. I have already mentioned that if it is a single server, just instead of C write 1. If it is a multiple server, then how many servers are there? 10, 15, 20. The value of n will replace that. Now let us come to D. Okay, let us come to D. A, B, C we have done. Let us come to D. Remember, D is the type of service. So for first come first serve, I will write FCFS. For last come first serve, I will write LCFS. For service in random order, I will write SIRO. For general service discipline, I will write GD. Okay, so these are the types of service available. Now come to E and F. Remember, what was E? It was the number of people in the system. E represents the number of people in the system. Okay, and remember, there were two models. Either it is finite or it is infinite. When I say finite, I have basically put a restriction on the number of people in the system. In that case, I will have to mention what is the restriction, whether there are 10, 15, 20, 25, 25,000, whatever may be, it will be represented by n if it is a finite system model. But if it is infinite, then instead of E, we will simply write infinite. I have mentioned here the symbol for both E and F represents finite or infinite. If finite, I will have to mention what is that finite value, and if it is infinite, then I will simply write infinite in place of that. Okay, so I think this part is clear to you. I think I am back. Sorry for this interruption. Am I live now? Yes, I am live. Guys, really sorry for the interruption. Really sorry for the interruption. I had to reboot the internet. I don't know, it is giving me issues for the past couple of weeks. I have complained also, but extremely sorry for that. So, let us continue. Let us continue. So, guys, basically, these names that I have mentioned here, these names that I have mentioned here on this page, these names, that I have mentioned here. Hi, Dinesh. Okay. So let me continue, guys. Let me continue. So these names that I have mentioned here, these are various types of queuing models. Okay. And every name that is mentioned here, is a unique queuing model. Is a unique queuing model on its own, because here basically whatever may be the parameters. Suppose I consider this queuing model. Okay. Then remember all the 6 names. simply means that both lambda and mu, both the value of lambda and mu, they follow Poisson distribution. Then 1 represents number of server, so it is a single server system. Only one server is going to provide us the service. Then FCFS represents that it is a service of first come first serve. Then N represents that there are finite number of people in the system. It is not an infinite model system. There are finite number, and whatever may be that limit, it will be given to you. Then infinite calling population means that there is no restriction to the calling population. The calling population is basically infinite. Okay, guys. So, guys, remember, it has been specifically mentioned in the syllabus of GATE. That we just have to study model 1. We just have to study model 1 and not anything else. Okay. Remember, if questions will come in the examination, they will come from model 1. But guys, I am not going to take any risk. What I am going to do, I am going to share the concepts which are necessary in order to solve the questions that are based on model 1, but I will also share those concepts via which you can solve the questions if other models may appear in the GATE examination. So let's say if there are different models, as I have mentioned right now, there are various models. So what I am going to do, that I will be discussing the questions of model 1 also, and I will be discussing the questions of some other models also, so that you guys can have an idea that how to approach those questions. Okay. Dinesh Kumar is asking Kendall's notation. Yes, Dinesh, what about Kendall's notation? Just now we have discussed Kendall's notation. Okay. Anything else? Dinesh? Chaliye, let me proceed, guys. Okay. Let me proceed. So, the first queuing model. Let me open my formula copy. So, here it is. So, guys, before I, what is this sign for? It is just a representation, Arunopal. It is just a representation, nothing else. Just a representation. So, guys, this is the model that we have to study. MM1 FCFS infinite. What it means? It means Poisson arrival, exponential service, single server, first come, first serve, infinite system, infinite calling population model. So guys, remember in this model, theoretically there is a possibility that there can be infinite people in the system. The calling population is also infinite. It is a first come, first serve system. And remember, this is the most important thing. It is a single server system. There is only one server in the system, and the lambda and the value of mu both are probabilistic, and they follow a Poisson distribution as well as exponential distribution. So this is what you have to understand first of all. Now guys, let me explain you little things. Let me explain you little things. Because basically what we are doing, we will be studying the first model. We will be studying the first model. We will be studying the first model so that we can calculate the length of system, the length of queue, the waiting time in the queue and the waiting time in the system. Okay, that's why we are studying the first model, because remember, through the data of the first model we have to find these four things. So I have already told you what is the length of system. It is the average number of customers in the system including those who are waiting in the queue. Okay, I have already discussed this. So what is the formula we are considering for the length of system? Guys, check out this formula, what it has been done here, that n into Pn. What is n into Pn? Then summation from 0 to infinite. Okay, so what it is basically doing, that if you want to find the length of system, okay, so what it is saying, suppose there is one person in the system. Suppose there is one person in the system. Do one thing, consider the value 1, multiply this by the probability of 1. I will tell you what it is. Then do what? Take 2% in the system, multiply this by the probability of 2. Take 3% in the system, multiply this by the probability of 3. Similarly, take 4%, multiply this by the probability of 4. And if you have an infinite system, that means there is a possibility that there can be infinite people in the system. Theoretically, there is a possibility. So you will be keep on adding this up to the possibility of infinite people in the system with the probability of infinite people. Now what I am basically doing, guys, I am using weighted average method, nothing more than that, weighted average. Okay, so what it is saying, let's say the possibility or the probability of one person in the system is P1. So basically I am multiplying 1 by P1. That way, whatever is going to be the probability of 1, if 1 has a higher probability, then in the value of length of system, the maximum weightage will come from 1. Let's say I keep on writing like this. I write 10 P10. Let's say the possibility or the probability of 10% in the system is highest. The value of P10 is the highest. Then 10 will get multiplied by the highest factor, and in the value of length of system, 10 will get reflected. I hope you all are getting my point. Guys, come on, give me a yes or no. If you are getting my point, just write a yes. All I am saying, guys, I am considering every possibility. I am considering every number that can be a possible situation as the length of system. Length of system basically means, on an average, what is going to be the number of people in the entire system, whether they are taking service or whether they are in the queue. Okay, so I am considering every possibility and just multiplying it by the probability that it holds. So remember, that particular event or that particular number in the system which keeps on occurring again and again. If I consider a very large sample of data, if I will gather a very large amount of data with respect to a shop or respect to a saloon, and if I find out that most of the time when I entered in the shop, there were 10 people in the system. then guys remember 10 will have the highest possibility, highest probability, and multiplying 10 with respect to P10, it will give the highest weightage to 10, and that will get reflected in the value of length of system. Okay, so I hope everybody is getting that. Similarly, there is a possibility of infinite people in system, although that possibility might be very less, but we will multiply infinite with that, and that way my friends I am getting a weighted average value of length of system. Okay. Similarly, the length of Q, the relation of length of Q, let me just minimize this slide, otherwise people won't be able to see this. If I am considering the length of Q, okay, so remember, what is Q? Q basically means number of people who are waiting in the line. It excludes the number of people who are getting service. It excludes the number of people who are getting service. Number of people in the system means all people who are sitting on the sofa plus all those who are getting the haircut. But length of queue means average number of people sitting in the sofa. It excludes the number of people that are taking the haircut. Okay. So because we have to study only a single server system, because we have to study only a single server system. Remember guys, I have already told you we have to study a single server system. So what will happen in a single server system? Only one person at a time will be taking the service. Only one person at a time will be taking the service. Okay. Sir, probability here also varies from 0 to 1. Guys, remember, whatever may be the number of events, whether I consider the probability of 1, 2, 3, 4, up to infinite, the sum of all probability will always be equal to 1. Whether it is any kind of distribution, whether it is likely event, unlikely event, whatever it may be, okay na? The sum of all probability, possibility will always be equal to 1. This you should remember. Okay, this is not anything new about. So remember, because it is a single server system, always one person will be getting the service, and if one person is getting the service, then the rest of them are in the line. So mark this what I have written here, n minus 1 into Pn. Why n minus 1 into Pn? Why n minus 1 into Pn? Guys, this one represents that very single person that is taking the service. Because I am finding the length of Q, here I have found the length of system. I am considering everyone, whether he is taking service or whether he is in the sofa. But here I am only considering those who are sitting on the sofa. So that's why I have excluded this one, and those probability factors remains the same. Those probability factors remains the same here. Okay guys, I hope you have understood. Similar way that we have added 1 into P1, 2 into P2, I will be doing here also. But remember, if one person is going to be the case, so 1 minus 1 will become 0. 1 minus 1 will become 0. Why? Because if only one person is there in the system, then he will be taking the service. He should not be waiting in the queue. But if there are two people in the system, then remember 2 minus 1, 1 will be taking service, remaining 1, 2 minus 1 will be standing in the queue. So 2 minus 1 into Pn will be the probability. I hope you all are getting my point. Guys, come on, give me a yes or no. Is it clear? Come on guys, give me a yes or no. Is it clear? Okay, let me move on. Now guys, check this out. Now we have understood how to calculate the value of LS and LQ. Now let us consider the values of WQ and WS. Okay? WQ and WS. Just consider one situation guys. Let me give you a good example. Suppose yes sir. Okay, nice to see that you guys are understanding whatever I am explaining. Guys, we have already missed 2 classes. I am behind my schedule on the YouTube session. That's why I am speeding up. So I hope you guys don't mind and this pace is okay for you because I am repeating things again and again. Okay, so now just consider one situation, my friends. Consider one situation. Suppose you entered into a system. Suppose you went to a barber's salon, and what you saw that there is a line, there is a queue. Okay, and you went on and you joined that queue. Now you noticed that you are the fourth person in that queue. Now you noticed that you are the fourth person in that queue. Now keep on listening, okay? What I am saying is that you went into a barber's salon and you saw that there is a line. You joined that line, you go and sat on the sofa, and now you are seeing that there are three persons ahead of you in that queue, or three persons are already sitting there on the sofa. You are the fourth person. You went there, you sat there, you joined the queue. So you are the fourth person in the queue. Now listen to me. Now you want to find out the waiting time in the queue. You want to find out how much, for how long you have to wait in that queue. You have to find out that. How to do that? All I am saying is that you went into a system, you joined the queue, you are the fourth person in the queue, three persons are already sitting there on the sofa. Now you want to know how long you will have to wait in that line, or after how much time, after how long your chance of getting the service will come. Let me tell you. Just you have to do one thing. You just have to wait in that system. The moment you arrived in the system, at that very moment, just start a stopwatch. The moment you arrived in the system, just start a stopwatch. And the moment the next person came in the system, after you, the fifth person to join the queue, just make sure that you switch off the stopwatch or stop that very stopwatch. Note that time. You know what you will get? You can get the value of lambda. What is lambda, my friends? It is average arrival. Average arrival. All I am saying is, if you have entered in the system and you have started a stopwatch, and within 5 minutes, you noticed, that another person came. Then I can say that in every 5 minutes, one person is arriving, or 1 per 5 minutes is the average arrival rate. All the data that I am going to consider here will be average data. All the data that I will be considering here will be average data, because remember, I have to find the average waiting time in the queue. So I am considering that the next person who came after me, after 5 minutes, has provided me with the average arrival duration, that in every 5 minutes one person is coming. So now what I can do? Remember, you are the fourth person. 3 person already came in front of you. If you want to become that person, who will be seeking service, who will be getting the service, then remember guys, you will have to be in that situation where 3 persons will be behind you. In order for you to be in the front seat, there has to be a situation where 3 persons will be behind you. You know that in 5 minutes, 1 person comes in the system. Then for you to join the queue as the fourth person, 3 persons have already joined that queue. That means if I multiply 3 by 5, that means 15 minutes on an average is required for the fourth person to join the queue. 15 minutes is the average duration for the fourth person to join the queue. So guys, if I am the fourth person and I want to be on the seat where I will be taking service, then remember guys, I will have to make sure that these 3 persons first go and take the service, then I become that person. And remember, the moment I will become that person, 3 persons will be behind me. So because 3 persons, 5 minutes every one person came. So that line of 3%, it happened in a duration of 15 minutes. And remember, again the line of 3% will happen in the next 15 minutes. So I can conclude from that with respect to 3 people in the queue, I will have to wait 15 minutes in the line or in the queue. So guys, this is nothing but Little's law. I hope you have understood. It simply says that if you want the waiting time in the queue, just find the length of queue, divide it by the average arrival rate. I was multiplying there 3 into 515. All I am saying is just find the value of length of queue, divide this by lambda, you will get the waiting time in the queue. I hope everybody got my point. I hope each of one of you understood. Similarly goes for length of system also. Just divide the length of system with lambda, you will get the waiting time in the system. And this law my friends, is called as the Little's law. Remember, Little's law is valid for a steady state condition. What is a steady state condition? Guys, if I am saying that lambda is 5 per hour, then lambda will remain for 5 per hour, whatever may be the span for which the duration for which the system is running. If I have calculated for a saloon that lambda on an average is 5 per hour, then this value will not change. I have fixed that value. With respect to time, these parameters will not change. That is a steady state condition. And yes, you have to make sure, because when I have calculated using the stopwatch, I am using that time to find these values. So if that value will change, my value will change. So remember, Little's law is valid under the steady state condition when all the parameters, whatever the information we are providing, they do not change with respect to time. The average number of items in a queue or system is given by the average rate at which the items arrive multiplied by the average waiting time that an item spent in the system. Okay, so if you simply want to find the waiting time in the system, just multiply the value of lambda with respect to the length of system, you will get the waiting time in the system. I hope guys you got my point. I hope you got my point. Nothing special in that. Now, one more thing we have to understand, that is utilization factor. Very important. Very, very important. What is the utilization factor? It is represented by rho. Okay, it is basically calculating the percentage of time for which the system is busy, or the percentage of time for which the service is getting utilized. ठीक है ना? Suppose I am saying that lambda rho is equal to lambda by mu. If I say that lambda is 3 per hour and mu is 4 per hour. What this means? It means on an average 3 customers arrive in the system in every hour, and on an average in an hour 4 customers get serviced from the system, leaves the system. So that simply indicates that the service facility is stronger. We have a better service facility. We are prepared for the worst situation. Okay, guys, answer one question to me. If I say that lambda is 3 per hour and mu is 4 per hour, on an average 3 customers arrive in the system in a duration of 1 hour, and on an average 4 persons leaves the system in a duration of 1 hour. So the question I am going to ask is, if lambda is 3 per hour, mu is 4 per hour, is there is a possibility of having a queue in this system? Is there is a possibility that we can have a line or a queue in the system? Answer my question with a yes or no. Sahil is saying yes, sir. The question that I am asking, guys, that if lambda is 3 per hour, mu is 4 per hour, the service facility is stronger. Is there is a possibility that we can have a queue in the system? Guys, Sahil is absolutely correct. Remember guys, when I say that lambda and mu, they are the average values. Sahil is correct. Listen to me. When I say that lambda and mu, then lambda and mu are the average values. When I say that lambda is 3 per hour, When I say that lambda is 3 per hour, that is an average value of lambda. There can be a situation when 30% can come in the system in an hour, or 3000 persons can come in the system in an hour if there is no limitation. I hope you all are getting my point. Lambda is just an average value. There will be a probability for lambda. But when I say 3 per hour with a probability, there is a chance that 30 persons can come in the system. And if 30 persons will come and I have a capacity on an average to serve only 4 per hour, then guys, what will happen? Q will happen. People will fall in line. So the value of lambda and mu, they do not decide whether you will have a queue or not. I hope you all are getting my point. When I will say that lambda and mu are deterministic values, when I say that lambda and mu are deterministic, 3 per hour is fixed, only 3% will come in an hour, and exactly 4% will get service in an hour, then line will never form. But because I use the word average again and again with respect to probability possibility, there can be a situation when 30% can come in the system and there will be a line in the system. Guys, is this clear to each and every one of you? So when I write rho is equal to lambda by mu, that is rho is equal to 3 by 4, that is 0.75. What it indicates? It simply indicates on an average 75% of the time the system is busy, or the service facility is getting utilized, or the service sector under the system is busy. When I have rho is equal to lambda by mu, that is 0.75, it simply indicates that the service facility on an average is busy for 75% of the duration. That is what is the meaning of utilization factor. Now, remember, the value of rho can be greater than 1, the value of rho can be equal to 1, and it can be less than 1. Okay, as we have seen here, the value of rho is less than 1 in case when lambda is less than mu. Okay, so whenever lambda is less than mu, the value of rho is less than 1. And whenever we have a situation that lambda is greater than mu or lambda is equal to mu, then in those situations rho will be greater than equal to 1 or equal to 1. So what does this basically signify? Why I am telling you all this? What is the significance of the value of rho? Guys, remember I have told you that we have to study at infinite model system. We have to study at infinite system. Okay, I have already told you that in the GATE syllabus we have to only deal with this model. And remember, in this model there is a possibility, theoretical possibility, that infinite people can be there in the system. Sahil Rana is saying no. Sahil, what no? Do you have any doubt? Sahil is asking all we are getting service. All we are getting service. What do you mean by that, Sahil? All we are getting service. What do you mean by that? Can you be more specific? Sahil, I am saying that the value of lambda and mu, they do not decide whether there will be a queue in the system. Okay, lambda can be greater, mu can be greater, whatever may be the situation, line can happen. Okay, line or queue can happen. That's why we are studying the queuing models. So Sahil, what is your doubt? Can you be more specific? All were getting service. What is your point? Is it a question or are you saying something to me? Okay, Sahil is not responding. Okay, let's proceed. If you will have a doubt, he will get back to me. So, remember guys, we have to study at infinite system. What is an infinite system? Basically, in the system, there is a theoretical possibility that infinite people can join the system. A theoretical possibility is there that infinite people can join the system. That means there is no restriction in the system. And remember, when I say we are basically considering a single server system. Then when I say a single server system, then one person will be taking service and the rest of them will be in line. And all I am saying that if there is a possibility of infinite people in the system, there is a possibility of infinite people in the line also. Infinite people in the line, possibility. No restriction on the line, no restriction in the system. I am not saying that I have only this much space in my shop, only this much people should enter here. It is like an ATM machine. In a desperate moment, like in case of demonetization, people will form line from one chalk to another chalk. Okay, so now because there is a possibility of infinite people in the system, and I have a situation where rho is either equal to 1 or greater than 1. Suppose I have a situation where rho is greater than 1 or equal to 1. What this simply means that the value of lambda is greater than mu. On an average, the value of lambda is greater than mu. Let's just consider one example. Lambda is 4 per hour, mu is 3 per hour. The value of lambda is greater than that of mu or equal to that of mu. 4, 4, 3, 3, whatever be the situation. But remember, rho should be greater than equal to 1. If I have a situation like this, in case of an infinite model system, what will happen? Just consider this situation. Suppose guys, suppose the system is running smoothly. People are coming, taking service, leaving the system. People are coming, taking service, leaving the system. Sometimes what happened, 2 or 3 people fall in line, but on an average, in the next few hours, no one came. So these people got their service and they also went away. But suppose at one moment, 100 people came in the system in an hour. Because remember, all I am saying that 4 is an average value. 4 per hour is an average value. All I am saying is 4 is an average value. That means there is a possibility that even 100 people can come in the system in an hour. So let's say if in a single hour 100 people came, suddenly 100 people came in the system. Sir, these are old comments, you are getting late. Okay, Sahil. I don't know, this is all YouTube. Okay. सर एलपीपी यूट्यूब में होगा क्या सर प्लीज बताइए यस डेसिमल पॉइंट एलपीपी यूट्यूब में होगा आफ्टर क्यूइंग थ्योरी आई विल बी स्टार्टिंग एलपीपी डोंट वरी बट व्हाई गाइस आई मीन यू आर हैविंग एन इंटरनेट कनेक्शन just like YouTube Unacademy platform is absolutely free. I have made that lectures there also. Why are you waiting for the lectures on YouTube? I will be conducting after queuing theory. I will be conducting the LPP model, and tomorrow is probably going to be the last class for queuing theory. And day after tomorrow, I will be starting LPP. Sunday, I will be starting LPP on YouTube. So no issues. Decimal point. Decimal point. What is your name? It is not nice to call you decimal point. Ashwin is saying that if rho is greater than one, system will be 100% more busy. Ashwin, let me just finish my point. You will be able to understand. So guys, where was I? I was saying that suppose in an hour 100 people came. Now you have a facility which can only serve 3% per hour. On an average, it can only serve 3% per hour, and suddenly a surge of arrival happened. A large crowd came in, 100 people came in. What will happen? All those 100 people will fall in line. Because the service facility is very weak, or this particular event of 100 arrival in an hour has dominated the service system completely. You will see a large line, a very long queue. And you know what will happen? Because this service facility is weak, and on an average, I have already said 4 persons will be arriving. So although there are 100 people in the line, and I am only providing service with 3 per hour on an average rate, and in that duration also, 4 at an average rate are coming. So guys, you know what will happen? This line will keep on growing, keep on growing, keep on growing. The service system will be pushing hard, busy all the time, pushing hard. But because the average values are like this, that 4 per hour is the arrival and 3 per hour is the service system will try to consume the line, will try to finish the line, but the line will be growing at a higher average rate then. And you know what will happen in this case? Somebody or other will always left out in the system. They will never ever able to receive the service. All I am saying is that this service facility with an average of 3 per hour won't be able to consume this line. They won't be able to give service to everybody in the line. That is what is going to happen. So guys, just mark my words. I hope you all have understood. I hope you all have understood. If you haven't, just give me a no, and if yes, then just write a yes. So guys, all I am saying is that if you have an infinite model system, never ever consider the value of rho greater than equal to 1. For an infinite model system, rho must always be less than 1. The arrival should always be less than the service, because if for an infinite system, because we haven't restricted the line, guys, if I would have restricted the line, let's say at 10, if I would have restricted the line, if say at 10, then this 100 people would have came, but 90 would have returned. They would not have joined the queue. But because there is no such restriction, theoretically there is a possibility of infinite people in the system, then we must ensure that the arrival must be less than the service, because if any possibility of this event is there, if 100 people came in once, then in order to consume the entire line, in order to provide service to all these 100 people and finish the queue, whether they have to work for all the time, whether they will be busy all the day, that doesn't matter. But then only when they have a stronger service facility with respect to the arrival on an average, then only they can consume that line or can provide service to each and everyone on that line. I hope guys, I hope everybody is getting my point. I hope you all are able to understand whatever I am saying. So guys, mark this thing, that for an infinite system, rho must always be less than 1. Rho must always be less than 1. So with that explanation, I am going to move on to the first first queuing model, that is MM1 FCFS infinite model, where I have a Poisson arrival, an exponential service, a single server, first come first serve, infinite system length, possibility of infinite people in the system, remember rho will always be less than 1, and infinite calling population system. So guys, what I am going to do, I will be generating the formulas of LS, LQ, WS, WQ with what general formulas I have seen here. I have seen the general formulas here. With the help of these formulas, I will be finding the values or the formula, generating the values or the formulas for the model MMM1 FCFS infinite. Guys, please check this out. This Pn. What is this Pn? This is the probability of n people in the system. When I am saying probability of 1, then it is P1, probability of 2, P2. So that is Pn. And how to find this Pn, that is the question. If I can find the value of Pn, I can just simply find these formulas. Okay now. Pn is the most important thing here. If I can find the value of Pn, I can find anything. So let's now concentrate on Pn. Okay, because remember, in order to find the value of these, I need Pn. Pn is very important. So let us concentrate on Pn. So now guys, I am going to write one formula. Pn is equal to rho to the power n P0. So guys, remember, queuing models are of a variety of types. There are n number of different parameters with which, having different permutation and combination, we can create a different queuing model. But if I consider just one situation, that the queuing model has steady state conditions. What the steady state word means? Parameters will not change with respect to time. With respect to time, my friends, with respect to time, the parameters won't change. What are the parameters? The value of lambda, the value of mu, the service rule, the number of servers. Whatever the 6 data points we are considering, those 6 data points, those parameters will not change with respect to time. If that is the condition, we can use this formula. There is a proper derivation of this formula, but that is not at all required for you guys. You remember, you are simply preparing for GATE and ESE examination. You won't be asked these derivations. Unnecessary, there is no requirement for that. Okay, just consider that for a steady state condition, and remember in GATE syllabus there is only one model, MM1 FCFS infinite, and in this steady state condition has to imply. So this formula is valid. Pn is equal to rho to the power n p naught, where Pn is the probability of n% in the system, rho is the utilization factor, and P0 is the probability of 0 in the system or system being idle. Probability of idle system. What is an idle system, my friends? When I say there are 0 people in the system, nobody is getting service, nobody is in the queue. Okay, so basically the system is sitting idle, nothing is happening in the system. That is the probability of 0 in the system. And what is Pn? Probability of n people in the system. People simply means it can be anything. Okay, na? So probability of n in the system. Let me just write this as probability of n in the system. And what is rho? It is the utilization factor that we have already seen. So guys, remember this formula is valid and we can use this formula straight away, that Pn is equal to rho to the power n into P naught. Now let me proceed. Now guys, I know that for an infinite system, I am discussing this so that I can explain you the first queuing model, MM1 FCFS infinite. So guys, I knew that for an infinite length system, the summation from 0 to infinite of all the possibilities will always be 1. What is this? It means that probability of 0 in the system, probability of 1 in the system, 2, 3, up to infinite people, all the probabilities, if I will just add them up, it will be equal to 1. Okay, so when I am saying that I have a system and theoretically infinite people can be there in the system, then there can be a situation when no person will be there in the system. There can be a situation when one person will be there, 2 there, 3 there, 4 there, 10 there, 15 there, 50,000 will be there. So what I am simply doing, I am adding the probability of all those possible events, and remember the sum of all the possible events, probability of all the possible events will be equal to 1. That is the first thing that you should understand. Now if I can write this line, if I can write this equation, then I can write P naught plus rho to the power 1 P1, P naught, rho to the power 2 P naught, 3 P naught, rho to the power infinite P naught equal to 1. Guys, I just converted this equation into this equation. How? Remember, for a steady state equation, I can write Pn is equal to rho to the power n P naught. And I have already considered the first equilibrium model to be a steady state model. The parameters will not change. It has steady state condition. So I can use Pn is equal to rho to the power n P naught. So I have simply what I have done, I have replaced P1 by rho to the power 1 P naught, P2 by rho to the power 2 P naught, and so on. Okay, now what I can do, I can simply take P naught out of this. So this will become 1 plus rho square plus rho cube up to rho to the power infinite is equal to 1. So guys, this is what? This is a geometric progression. This is a geometric progression. And in this geometric progression, we have the sum from 1 to infinite. What is the sum of a geometric progression from 1 to infinite? What is the sum of a geometric progression from 1 to infinite? The sum is given by the relation 1 by 1 minus r. What is r here? R is rho here. This is the general equation, है ना, for sum. So what is this? This will become P naught 1 by 1 minus rho equal to 1. But the only condition is that for this relation that r should be less than 1. R should be less than 1. Okay now. So guys, for this the implication is that rho should be less than 1. And remember, I have already considered that. I have already considered that for an infinite system rho will always be less than 1. So here mathematically we are basically proving that rho is less than 1. And I can finally write here in the box, I can finally write P naught is equal to 1 minus rho. P naught is equal to 1 minus rho. This is what I have derived. This is what I have derived for an infinite system, single server, steady state queuing model. Okay. So whenever there is an infinite system, single server, steady state model, steady state queuing model. Okay. Remember, for an infinite model, this condition is necessary. Rho should be less than 1. The probability of 0 in the system is 1 minus rho. The probability of 0 people in the system or the probability of system being idle is 1 minus rho. So this is the formula that you can use for every infinite model system with a steady state condition. Okay, this formula is valid for every infinite model. Again, I am saying infinite. If there will be a finite system, this formula will not be valid. So guys, I hope this is clear to you. Up until this point, it is clear. So now, because I have the value of P naught, what I can do? I can write the value of Ls. What was Ls? Just let me write it down. From n to 0 up to infinite, for an infinite model, npn. This was the formula, guys. Come on, check this out. This was the formula. npn. Ls was npn from 0 to infinite. Okay. So I am just simply going to write that. This will be 1 into P1, 2 into P2, 3 into P3, infinite into P infinite. Then I can write 1. Instead of P1, I will be writing rho P naught plus 2 rho square P naught plus 3 rho cube P naught and up to infinite. Okay. So guys, through this what I can say, I can simply take rho out of here. I can simply take rho out of this. Okay. And I have already proven that for an infinite system, P naught is equal to 1 minus rho. So I can put P naught is equal to 1 minus rho in this case. P naught equal to 1 minus rho in this case. So this will become Ls is equal to rho by 1 minus rho. This is the final relation, friends. This is the final relation. And this relation is valid. Remember, only for an MM1 FCFS infinite queuing model. For a MM1 FCFS infinite queuing model, the length of the system has a formula rho by 1 minus rho. Okay, I have simply in this relation solve the geometric progression and place P naught is equal to 1 minus rho, I have got this value. Just by simply putting that, you can also obtain that. Now let me find the value of LQ. So remember the relation for LQ was summation from 2 to infinite n minus 1 pn. So guys, simply again solving this, opening everything and using the equation P naught is equal to 1 minus rho, I will get the value of LQ as, just note down the formulas, no need to completely solve the derivation. You can just simply note down the formulas. Rho square by 1 minus rho. Hi Anmol. Sir, P naught is in the power. P naught is not in the power. P naught is not in the power, my friends. P naught is not in the power. It is multiplied. Okay. So this is the formula for LS, length of system. This is the formula for LQ, and we already know that WS is equal to LS upon lambda, and WQ is equal to LQ upon lambda. This is Little's law, and we have already established this, already understood this. So once we have found the values of LS and LQ with the help of formula, we can easily calculate WS and WQ. We can easily calculate WS and WQ. So guys, at this point I would like to ask whether everything is clear to you or not. Up until this moment, whatever we have done, is it understood? Come on guys, tell me, is it understood? So guys, just note down these formulas, if you can. Otherwise I will be sharing the PDF. Guys, remember one thing, this formula of LS and LQ that we have derived is for the model 1, that is MM1 FCFS infinite model. Okay, and guys, tomorrow we will be solving numericals on this. Tomorrow is going to be the last class of queuing model, the third class, and we will be solving numericals in that class. Very important class, because whatever we have studied up until now, we just have to apply that and check that how it pan out. Okay, we will have to solve numericals using these relations that we have developed, and we will have to find out that whatever we have understood, whether we can apply that or not. So tomorrow is going to be the last class of queuing model, and then I will be starting LPP on YouTube. So guys, let me just discuss the schedule once again with all of you so that everyone can get benefit out of this. Guys, in the morning on the Unacademy special class, okay, from 9 to 11:30. There are two sessions, in between there is a gap of 30 minutes. So in these two sessions on the Unacademy special class, I am conducting Manufacturing 2020. In a very unique way, we are studying manufacturing on the special classes. You can join us. It is absolutely free. Okay, the link of which is provided in my Telegram channel, and I share every day on Facebook as well, and on other mediums of social media as well. I try to share. Otherwise, you can simply go on the Unacademy app, search my name Manish Mishra there, and there in the special class category, just enroll in whatever classes that are there. Any other topics left considering those special classes? Arunopal, I did not got your point. Any other topics left considering those special classes? I did not get your point. Can you be more specific? So come on guys, let me just concentrate here. So guys, tomorrow is going to be the last class, that is Saturday, that is going to be the last class of queuing model 3, queuing models, last class, the third class. And Sunday on YouTube I will be starting LPP at 9:15 p.m. So those who want to continue with LPP, they can join with Sunday's session. Okay guys, so that is it for today's session. Let me just sum up this session because time is already over and I have to provide you with the subscription pitch. So guys, as I have already said again and again, that if you want to prepare, so assignment problem will be covered on YouTube. Karthik, everything will be covered on YouTube. You guys do not have to worry about anything. Everything will be covered on YouTube. The entire syllabus of industrial engineering and operations research, it will be covered on YouTube. Okay. So guys, remember the Unacademy Plus subscription as well as the Iconic subscription. If you want to have a full-fledged preparation, do make this investment guys, do make this investment. The special classes and YouTube classes are there to help you guys so that you can start your studies. You can at least get an idea that these examinations are not that tough and everybody or anybody can prepare for that examinations. And these YouTube classes and special classes are there to titillate you, to remind you that yes, you can also do, you can also perform. But if you want to have a full-fledged preparation, because remember, without the full-fledged preparation, without considering all the areas, arenas, domains, you won't be able to score that well in the GATE examination. I mean, if your potential is there, if you have the potential to score or secure an All India rank of let's say under 100, then you can only achieve that if you have the proper guidance, you have the proper tools, and you have taken your preparation in a manner which makes you highly competitive. And for that, guys, you have to take that extra edge, and for that you need to have the plus subscription or the iconic subscription in whichever you feel comfortable, whatever is the level of investment that you can make. Remember, I am saying this as an investment. This is an investment, it will unfold in future. Okay, the Unacademy Plus subscription has huge benefits. There are various different batches going all around the year. Different group of teachers are teaching there. You can study different subjects through different teachers via joining different multiple batches also. And with respect to batches, what happens? Teachers usually provide the entire schedule in advance. So basically, you know what day at what time what is going to happen. That teacher is going to take what class. And remember, every fourth class is a doubt solving session. That is also incorporated in the schedule. So guys, you can take benefit of all of this. And most important, tests. These tests have been formulated by some very senior faculty, some top level educators at Unacademy. And students who are giving these tests on the Plus platform, they are getting proper analysis. Whatever mistakes they are making, teachers are guiding them how to improve on those mistakes. So that is the power of Plus subscription. And I must advise, this is a must advice from my side, that go for the Plus subscription. And guys, if you are going for the Plus subscription, remember to use the referral code MMM10 across any subscription that you will take on Unacademy platform. This code MMM10 can fetch you a discount of 10%. Okay. Okay. Good night, Arunopal. So guys, remember that code MMM10 will fetch you a discount of 10% across all the subscriptions, all permutation combinations available across the Unacademy app. Guys, this is my profile on the Unacademy app. If you haven't yet followed me, please follow me on the Unacademy app. Just go check out this URL, type this on the URL section, and you will be straight away directed to my profile page on the Unacademy app. Simply follow me there so that the notifications of my future classes can reach you. Guys, this is my Telegram channel. Take this link, okay? Take the screenshot of this link. Join me on my Telegram channel. There I share all my PDF notes. These class notes are going to be shared on the Telegram channel today only. This is the Unacademy GATE Mechanical PIXI YouTube channel, which I every day goes live on at 9:15 p.m. So yes guys, thank you all for watching this session. I will see you all tomorrow in the morning at 9 a.m. on the Unacademy app with Manufacturing 2020. and tomorrow at 9:15 p.m. in the evening with the continuation of queuing models. Up until then, bye bye guys. Please share this info with your friends. I will see you all tomorrow. Good night.